Hello Year 12 and welcome to the 8th and last video here for our topic on trig functions. Okay, we've covered all sorts of things so far, but most recently we looked at integrating trig functions, and finally we're going to wrap up here with applications of integration. Okay, our applications tend to be area or volume. Okay, now a tip here, sketch is important, right, because most of the functions that we'll be looking at have areas above or have sections of that function that are positive and negative, that are above and below the x-axis. So we have to be careful about cancelling areas out if we're talking about area under a curve. Right, now this example here is a good example of how that works. We want to find the area between the curve of cos half x and the x-axis from 0 to 2 pi. Now, it doesn't just say integrate this from 0 to 2 pi. In which case, signed area is fine. It can cancel out. I can get a 0, which is what would happen here. Now, in this case, we're going to start with the sketch. Now, remember, cos x starts at 1, dips down and back up again. And if I put something in front of the x, if the x has a coefficient other than 1, then that relates to the period. Okay. Now, the way that I like to interpret this is that it tells me that I will, over the course of 2 pi, get exactly half of a cycle in. Right? Alternatively, my period is going to be 4 pi. Right? 4 pi would be the period there. So, let's sketch this up first. I'm going to get half of a full cycle in, which is going to go from here to here, or equal to, so I should colour those in. Oh dear, that's a bit wonky. I don't care for that much at all. Oh well. Sorry guys. There's my y-axis. There's my x-axis. This here is at 2 pi. This here is at pi. You can review that if you like. That's at 1, -1, not that matters too much. And I want this area plus this area here. So I want to find the integral from 0 to pi of cos half x dx. I'm going to say minus. Oh, well, we've got a couple of options. I could do minus this integral because it's a negative area, or what I'm going to do is I could say plus the integral. Right, if I run it backwards, remember 2 pi to pi of cos half x dx. Running it backwards gives you a negative result. Okay. Now, the integral of the cos of half of x, right? So it would look something like sine of half of x, but if I were to differentiate sine of half x, I would get half cos half x. I don't want that to be the case. So let's say it's going to be 2 sine half x. Right, you can confirm that's the case. Differentiate that. I get half times 2 is 1. I get cos of half x. All good? I get this one from 0 to pi plus the same thing again, 2 sine half x. This time from 2 pi to pi. Okay. Now, the sine of pi over 2. If you can remember this, the sine of pi over 2 equals 1. So it's 2 times 1 minus, now, the sine of half of 0. The sine of 0 is 0. Minus 2 times 0. Plus, we're going to have 2 times the sine of pi is 1, so 2 times 1 minus, now 2 times 2 pi is 0 again, minus 2 times 0 equals 2 minus 0 plus 2 equals 4 square units. Okay, so there's a little bit of trickiness in there that we have to remember how to sketch these things. We need to remember some of the stuff about amplitude and period, okay, so that we can essentially work out where our zeros are. Right, which parts are positive and negative. And that brings us all the way through to the end of our unit on trig functions, not just the exercise but the whole unit. Right, I hope that's some help. I'll see you in class.